Okay, class. So we're on page 17 from the homework or the classwork, depending how it was assigned. And right now we're going to be doing questions 1 and 2. On questions 1 and 2, they tell us that they give us a diameter of 13, and they want us to find the radius. But we know that the radius is always half the size of the diameter. So if the diameter is 13 inches, the radius is going to be 6.5 inches. For number 2, they tell us that the diameter is 8, so we know that the radius is going to be 4 centimeters because it's half of the diameter. For number 5, we're going in reverse. For number 5, they're giving us the radius and they're asking us for the diameter. So if I have a radius of 17 centimeters, well, I'm going to multiply that by 2 and because the diameter is twice as big, and 17 times 2 is 34. So my diameter would be 34 centimeters. For number 6, my radius is 6.3 feet. So again, my diameter is going to be twice as big. So 6.3 times 2 gives me 12.6 feet. Now let's take a look at questions 9 through 16. And it has to do with this image here. Okay, so for questions 9 through 16, we're just going to match them up to the correct side, to the correct answer here. Number 9, F. Well, if we look at F here, we notice that F is a tangent point, a point of tangency to circle H. We can just see F is just a point here. So that means that it's a point of tangency to circle H, and that would be letter E. Number 10, notice the double arrows above the two letters, so that lets you know that you're talking about line FE. Line FE. So if we look here, here's my F, here's my E, here's line FE. And if you notice, line FE is tangent to circle H, and it's also tangent to circle C. And if you notice, it's in between the two circles. So we could say then that it's a common internal tangent. So number 9 is letter G. A common internal tangent. If you look at number 11, now, we don't have the double arrows above H and G. So we're just referring to a segment here. We're referring to segment HG. So if I look here, here's H, here's G. I'm just referring to this segment HG here. And if you notice, that's a radius. It's going from the center of the circle to the edge of the circle. The circumference, to the edge of the circumference. So HG is in fact a radius, which would be letter D. Let's take a look at number 12. Number 12, again, I have a segment symbol above here, so it's segment DB. I look for D, I look for B, and if I notice here, DB, segment DB, is touching two parts of the circumference of circle C. And if you notice, it's not even going through the center. So what do we call a segment that touches the circumference at 2 points? That would be a chord. So number 12 is a chord. Number 12 would be letter B. Segment DB is a chord. Now we look at a C. Well, C is a point. Here is point C. It's at the center of my circle. As a matter of fact, it gives the name to this circle. This circle would be circle C. And it is at the center, so number 13 will be letter A. Again, for number 14 now, I have a segment symbol, so I'm talking about segment BE. I look for B, I look for E. Now, if you notice, this segment is touching one end of the circumference, going through the center, and touching another edge of the circumference. And if you notice, that is a diameter. Now let me ask you a question. Is a diameter a special kind of chord? Is a diameter a special kind of chord? If you answered yes, you answered correctly. A diameter is a special kind of chord that just happens to go through the center of a circle. So we're going to say that number 14, it is a diameter. So number 14 is letter C, a diameter. Okay. Now, if you notice for number 15, we have the double arrows for DB. That means we're talking about line DB. So I find D, here's B. So I have my line DB, not the segment, the line, which is going straight through the circle. And if you remember, we said a line that goes straight through a circle is known as a secant line. It is a secant line. So number 15 is H. Number 15 is H. And for number 16, again, we have line AG. We have line AG. So looking at line AG, here's AG, but it's a line. It's going on forever and ever. And if you notice, it's line AG is tangent to circle C, and it's also tangent to circle H. So it's a common tangent to both of these circles, and it is on the exterior of both the circles. So number 16 is a common external tangent, which is letter F. Number 16 is a common external tangent, letter F. Let's take a look at questions 21 and 22. For question 21 and 22, it is asking us whether line AB is a tangent to circle C. They want to know, is this line here, is line AB, is it tangent? Excuse me, I highlighted the wrong thing. That's AC. I'm sorry, guys. Here is AB. Here is AB. I'm sorry. They want to know if AB is tangent to circle C. But if you remember, the rule says that if AB is tangent to circle C, then AB is perpendicular to its radius, meaning it would make a right angle. And if it does make a right angle, then this should be a right triangle. And if it is a right triangle, then 8 squared plus 12 squared should be equal to 17 squared. The Pythagorean theorem should work if, in fact, it is a right triangle. So let's work that out. Let's work that out. If I look here, I have 8 squared plus 12 squared is equal to 17 squared. So if it works out, then I know that line is tangent to my circle. 8 squared is 64, 12 squared is 144, 17 squared is 289. When I add them together, I get 208, but 208 is not equal to 289. So the answer is no. It is not tangent to the circle. Line AB is not tangent to the circle. Let's take a look at question number 22. 22, again, they're asking me if AB is tangent to circle C. So let me highlight that here. So if it is tangent, then I know that it should be perpendicular with this radius here. And if it's perpendicular with this radius, I have a right triangle, and then the Pythagorean theorem should work out. So let's take a look here. I have 7 squared plus 24 squared is equal to 25 squared. It should work out if that line is in fact a tangent. 7 squared is 49. 24 squared is 576. 24 squared is 576. 25 squared is 625. I add them together. 625 is equal to 625. So the answer is yes. The answer is yes. That line is tangent. Line AB is tangent to circle C. Let's move on to questions 23 through 25. For questions 23, I see here that I have one tangent line and another tangent line coming from a common point which is outside my circle. And if you remember, the rule for that states that if you have tangent lines to circles coming from the same exterior point, then those two lines should be congruent, meaning that I can set these two equations equal to each other, and then I should be able to find x. So let's work that out. For question 23 then, let's let that focus a little bit there. There we go. For question 23, I set my equations equal to each other, saying that 7x minus 2 is equal to 3x minus 8. Some basic algebra. First step. Second step. Third step. We get 4x equals to 10. Divide both sides by 4. And x is equal to 2.5. So we can solve that x is equal to 2.5. So at first, this question might seem a little bit complicated because you're dealing with a circle, but in actuality, it's a simple algebraic equation setting these two equations equal to each other, and we can solve for x. Number 24 is the same thing. I have two secant lines coming from the same external point. So then I know that these two, tangent lines, I misspoke there. I have two tangent lines coming from a common external point. So these two should be congruent to each other. And I'm going to set out my equation here as such. I know then that I'm going to solve for x, which is going to give me that. When I subtract, I'm going to get x squared is equal to 25. But now I have x squared. So to get I'm going to take the square root of both sides. And the square root of x squared is x, and the square root of 25 is 5, so x is equal to 5. And the last question, number 25. Again, I have the same situation again. I have two secant lines. I have two, I keep saying secant, I'm sorry. I have two tangent lines. I have two tangent lines which are coming from an external point. So I know that these two should be equal to each other. I'm sorry, guys. I don't mean to confuse you on that. I don't know why I keep saying that they're secant lines. They are tangent lines. So here, I'm going to set my two equations equal to each other because they should be. The two lines are congruent. I'm going to divide both sides by 3. X squared is going to be equal to 4. I want to solve for x, so I'm going to take the square root of both sides. The square root of x squared is x. The square root of 4 is 2.